It is not uncommon to hear, "I don't like doing geometry proofs. I don't get it." As we know, wondering when will I ever use this in real life often crosses the mind of many geometry students. So why do schools include this in their curriculum? One response is that geometry proofs will help develop strong reasoning capability. While this is true, it does very little to convince, or more importantly, to motivate our students. Many of our examples and exercises seem to reinforce the student's impression that geometry proofs serve no useful purpose other than passing the math test. If it's clear by inspection that figure ABCD is not a triangle in the example proof, why go through the trouble to prove it? The reason is that although our senses give us the correct answer this time, they are not as reliable as we think. The following examples will demonstrate that dependence on our senses alone might lead us to inaccurate conclusions. Daily experience tells us that objects always appear smaller in the distance and larger up close. When we see a bird in a nearby tree that looks much bigger than an airplane in the sky, we know our senses are not revealing the truth. If we stand and look down a railroad track, the rails seem to meet at some point in the distance, although we know they need to be parallel in order to support a train. This is because our perception of the size of an object is affected by the size of the image on the retina of our eye. As the object moves further away, the angle between its most distant points gets smaller, and so does the image on the retina. Even simple geometric figures, lines, and line segments can be visually misleading. The two line segments shown are congruent. However, most of us would get the impression that line segment AB is shorter than line segment CD. In the next figure, the two lines shown are straight. However, because of the many lines intersecting lines A and B, many of us would think the lines are curved. If our senses cannot give us reliable answers regarding these simple figures, how can we trust their conclusions when dealing with real-life problems full of even more distractions? Another example that shows our vision can easily be fooled is the closed loop, Escher-type stairs. It is always ascending clockwise or descending counterclockwise. Mathematically, we can easily prove these types of stairs do not exist in reality. Again, as demonstrated, we cannot rely on our senses to make critical decisions. To make a correct conclusion, we need to utilize a method such as mathematical proof.